1, Lesson 3, Explore. There is a lot of words on this page and some really kind of intense-looking fractions. Explains on there what we're doing. So I wanna. You can read all that, but I also just want to start with the first problem, and I'll explain. Okay, since this is the video part, you can always read the other part. Basically, you're handed a equation. Not an expression, but an equation. It has an equal sign. You can handle equations much easier than expressions because there's a couple of different things you can do to handle the problem. You can move this 7 over 2, add 7 over 2 to both sides to move that fraction over, and then you have to combine by adding fractions, and you don't have like denominators. So there's a couple of problems to come up. So there's one way to suggest to clear the fractions and then process this equation without the fractions in there. So you need to do that step, you need an LCD, okay, to clear these fractions out, all of them at the same time. All right, so we need a lowest common, least common denominator that's a 4, a 2, and a 6. So think about it. This is how I do this. My brain goes to the first, to the largest exponent, which is a 6, and I look and I see the 2 does go into the 6. So I could use a 6 as an LCD if we just had 2 and 6, but then I also have a 4, and 4 is not a factor of 6. So I go through the list of 6. So 6 times 2 is 12, and right away I get a number that the 6 and therefore the 2 and the 4 go into, which is a 12. So my LCD is 12, okay? So if I use this least common denominator to clear my fractions with, this is how we do this. Once I decided on the LCD, I multiply each term in the equation by that LCD. This is the way I write that out. I actually write it kind of up at the top, but if you think about it, this is really 12 over 1 times 3 over 4. That's really what you're doing. And that's a variable term. It has an x, okay? And then there's a subtraction sign. Don't lose that. And then this one is literally 12 over 1 times 7 over 2. So I don't write this all out this way every time, but I'm just trying to explain for the first time, okay? And then there's an equal sign, and then this is going to be 12 over 1 times 5 over 6. That's what your thinking is, okay, when you're clearing your fractions, because what's going to happen is you're going to multiply across. This is how we multiply fractions, right? This is going to be 36 over 1 times 4 is 4, which is a 9x, okay? And then you go over here, 12 times 7, and then divided by 2, it says 84 divided by 2 is 42, okay? And then this is, I should write that down, 84 divided by 2 is 42. And then this is what, 60? 12 times 5 divided by 6, which is a 10, okay? And that way you're only working with this as your equation now, and that certainly looks a lot better than that, okay? And then you process the rest like you would any regular equation, right? What's the goal? We want to get the variable term, x term alone on one side, so we're going to move the 42 by adding its opposite to both sides of the equation. That's going to leave us with 9x equals, that goes away, and this is going to be, 52. Let's add, hang on. Right here, get ahead of myself, 52. All right, and then isolate the variable by dividing by 9. So you can imagine that if you do an equation with a bunch of fractions, you have a good possibility of getting a bunch of fractions for your answer. Okay, so let's try the next one. If I can get, I may have to erase this one. Hang on, sorry. So let's do them with lots of space here. So the next one is 2 over 3x minus 2 equals 3 over 2x plus 1/6. Lots of fractions. I'd like to clear those all out, okay? My denominators are 3, 2, and 6, and if I use 6, the largest one, that'll take care of the other two. So what I want to do is multiply every term in this equation by that 6. Notice I also multiply this term here that doesn't, it's not a variable term, it's a constant, right? But we still want to make this an equation and keep it an equation. We have to keep each side balanced. So if I touch one side, I need to touch everything on there, so it's going to be the same still, and it'd be an equivalent fraction, okay? So this is going to be 6 times 2 divided by 3. That's going to turn out to be what? 12 divided by 3 is 4, right? And then this is just 6 times 2, and there's nothing to divide it by, so it's a 12. Oops, I almost forgot my x here. X equals 3 times 6, sorry, divided by 2, 9x. The way I do it, let me show you how else I do it too. The reason I'm going a little slow is because I don't typically write this section right here. What I do is I go 3 into 6 goes 2, and 2 times 2 is 4, okay? This is a 12. This is 2 into the 6 is a 3. 3 times 3 is 9, okay? And then 6 into the 6, I could write all this out, but basically I'm doing that, okay? So that's my new problem. 4x minus 12 equals 9x plus 1. I don't think about all these things that are up here, okay? This is my new problem. And I want to focus on the fact that I have a variable term with an x on both sides. I tend to move every variable to the left. Some people move it the other way to avoid negatives. I don't feel that's necessary, but and then that's going to be gone on that side, and that means that I need to be moving this way. So I like to write them vertically underneath each other, and I make sure I'm only crossing out one thing on each side, okay? So this is going to be negative 5x equals 13. And divide by 5. So this is going to be a negative 13 over 5 for that one, okay? And then there's one more on the page that has a distribution. Let me get rid of these things. All right, so 1 over 4, negative x minus 1 equals negative 1 over 12, 2x minus 3. All right, so when you have a distribution, it's a little different. I just finished saying on the other ones that you need to multiply the LCD by every term in the problem. Of course, there's one exception when I have a distribution, okay? You can distribute, so there's two ways to do this. You can distribute this 1/4 into both of these terms and the negative 1/12 into both of those terms. But I like to clear my fractions, so I'm just going to multiply by the LCD by this term here, with the LCD is 12, and this term's here, right? I have a 4 and a 12. So 4 goes into 12, so 12 is my LCD. And 4 into 12 goes 3 times, so this whole thing just turns into negative 1 to x minus 3. Notice that I didn't touch the terms in there. Think about it this way. This fraction was about to be distributed into this term and this term. So if I change it here and change it here, I'd be double changing. So you just, with a distribution, would be the one exception to touching everything. You want to touch all the terms that are outside parentheses. Okay? So that gets us here, and then you want to distribute. This is a positive 3 times a negative 1, positive 3 times a negative 1, negative 1 times a 2, negative 1 times a negative 3, oops, forgot my x, plus 3. Okay, and then I want to move this x, this variable term, back over here. And that means this one's going this way. So this is just going to be a negative x equals a 6. And then I want to isolate my variable. Remember, there's still a negative 1 in front, so we want to divide everything by negative 1. So I'm going to get x equals a negative 6. Okay? And I'll do the practice on another video.